Good morning students, my name is Suvas Vora, Assistant Professor of Electrical Department at Sri Swaminarayan Institute of Technology. So we are already started the chapter number 2, Power Quality Management subject, and the chapter name is the Power Frequency Disturbances. So in the last lectures we can see the sources and the causes of the voltage sag. So, in the term of the power frequency disturbances, describe the event that's slower and the longer lasting compared to the electrical transactions. Then frequencies can be last anywhere from the one complete cycle to the several seconds or the minutes. यानी कि जो डिस्टर्बेंसेस होता है, जो हमारी फ्रीक्वेंसी है उसमें लास्ट साइकिल में वो डिस्टर्बेंसेस होता है. सो व्हाइल द डिस्टर्बेंसेस कैन बी नथिंग मोर देन द इन्वॉल्वेंस expressions itself as the flickering of the light or the pumping right in the elevator. So this type, जैसे हमको फ्लिकरिंग यानी कि जो हमारे घर पे जो लाइट चेंजिंग होती है, फ्लिकरिंग होती है वो. So there are the three main considerations as a common power frequency disturbances: the voltage sag, it's also called the voltage dip, then voltage swell, and the voltage vibrations. So these are the, you can see that these are our normal waveforms. These are the sag and these are the swell. The another one is the harmonics, is the disturbances to vibrate. Voltage disturbances लिखा है या voltage vibrations लिखा है, this means the harmonics. So one of the most common power frequency disturbances is the voltage sag, and by the definitions, the voltage is an event that can be last from the half of the cycles. So the voltage sag, the causes is the motor. Motor में क्या होता है? We know that in the initial conditions the motor get the more power. So because of the voltage sag is arise, just like here you can see that the red. Then after the switching operations, it means that when the switch is on and off continuously at that time, the power make the voltage sag. You can see here. An unexpected fault, यानी कि हमारी लाइन में जब unexpected fault होता है तब there are the one jump in the systems. So these are the basic causes of the voltage sag. So the causes of the voltage sag is the static of motors, then transformer energizing model, then single line to ground fault, utility systems, then equipment faults, poor weather conditions, then pollutions, then freezing, then vehicles, then constructions of buildings, and the last one is the arc furnace. So where do they occur? In the service systems, then inside the plant. So you can see that these are our service system. If the fault in the zone 1, so they have also affect the zone 2 and up to the zone. If I consider the plant, अगर plant में होता है तो this type of fault is arise. So the factor that affect the voltage sag is, the first one is the type of faults, then locality of the fault occurrence, then X by R ratio, and transformer configurations. And the last one is the type of load connections. So now today's topic is the types and the characteristic of the voltage sag. तो जैसे ही हमने देखा कि voltage sag is the main effect of in our power systems. So there are basically there are two types of voltage sags. The first one is based on the phase, and the second one is the based on the fault. So based on the phase, we know that the single phase, two phase, and the three phase systems. So the single phase sag is nothing the most usually from the voltage sag In our power system, the 70% of this fault occurs in a single phase because of the phase to ground fault, and these come into the view of the single phase voltage sag from the other feeder of the same substations. Okay, now the two phase systems, they appear the less than the 10% of overall voltage sags on other feeder of the same substations. The causes of the two phase are the normally caused by the three branch, undesirable weather conditions and the animal contact and etc. And the last one is the three phase sag. So this type of sag is less than the 20%, and the causes of the switching, tripping and starting of the motor. So these are the based on the phase fault or voltage sag is a voltage sag types. Now the based on the fault on the transformer winding and the load conditions. So you can see here, the first is the type A. So the type A have the three phase to ground fault, then configurations is the delta to star connections and the 120 degree in the RYB phase. You can see here. So the equations is the V is equal to V, then P is the minus 1 by 2 V minus 3 root 3 by 2, यानी कि 120 degree apart. In similar way, the C is 120 degree apart. Then after the type B, so type B have the three phase to ground fault, and the configurations is the star to star connections. So the equation you can see here. So there is the no drop in the Y and B, but the drop in the R. Then after the type C, so these of the three phase to ground fault, the configurations is the delta to star, and there is the no drop in the Y phase, but the drop in the B and R. Then after the D, in similar way you can see that the configuration is the Y and Y, it means the star to star, and there is the no drop in the R and B, but the drop in the R and Y, but drop in the B. In similar way, the type of E configurations is the two phase to ground fault and the star to star connections. So there is the no drop in the R and B, but the drop in the Y phase. In similar fault F and G. So these are the based on the fault of the transformer winding and the load connection systems. Now the next topic is the characteristic of the voltage sag. So the characteristic of the voltage sag is depends on the magnitude, then durations, phase angle and jump, then missing voltage, then balanced and unbalanced, then point of the initiations, last one is the point of the recovery. So in the first one, the method of the finding the magnitude of the voltage sag. So the magnitude of the sag is nothing but the consideration as the left out the voltage during the occurrence, यानी कि जो मैग्नीट्यूड है हम वो कंसिडर करते हैं कि जो हमारा जो वोल्टेज ड्यूरेशन होता है तब लेफ्ट हो जाए. सो द RMS रेट ड्यूरिंग द सैग इज नॉट स्टेबल एंड हेंस दे डू नॉट रिटर्न बैक टू द ओरिजिनल वैल्यूज. So if the sag is the symmetrical, the least value of the voltage that corresponding phase can be utilized to find the sag. So the method to finding the magnitude of the voltage sag is the RMS voltage method, then peak voltage method, and the one cycle window algorithm. So in the RMS voltage method is nothing but it is the represent the graph of the time where versus the RMS voltage, and using this method we can find the sag is calculated by the sampling of the point with respect to the time, and thus the RMS voltage is calculated. Then after the peak voltage method, in the peak voltage method sag is determined by calculating the peak value from the fundamental waveform, and we can consider the pure sinusoidal waveform is considered for the calculation of the purpose. Then after the one cycle window algorithm, so in this find the RMS value within the one fundamental waveform, and the half cycle in similar way the half waveform of the fundamental waveform. So the magnitude of the voltage sag mainly depends on the types of the system and the fault susceptibility, then distance from the fault to the system, and this is because we can find the voltage can be calculated using the method. So here second one is durations. So durations is nothing but the reductions in the voltage during the sag is due to the short circuit conditions of the short circuit fault conditions, and this is instant. These faults are cleared by the gear protection systems and the voltage is resumed back. So we can say that the durations of the sag is mainly determined by the clearing the time. जो फॉल्ट क्लियर होने में जो टाइम लगता है उस पर डिपेंड्स है. सो दिस इज़ मेनली ड्यू टू द रीजनरलाइजिंग ऑफ द ट्रांसफॉर्मर, यानी कि रीजनरलाइजिंग ऑफ द ट्रांसफॉर्मर जनरेशन वापस जो ट्रांसफॉर्मर है वो रिबैक होगा. सो द ट्रांसमिशन लाइन फॉल्ट आर क्लियर्ड एट द फास्टर रेट दैन द distributing line faults, hence the fast responsive positive response of the circuit breaker are essential. Then after the phase angle jump, so sudden change in the phase is called the phase angle jump, and this is occurs to find the difference in the x by r ratio of the supply to the of the feeders. So the phase angle jump is the manifests itself as the shift in the zero crossing of the direct voltage. Then after the missing voltage is nothing but the divergence between the voltage without sag and the voltage during the sag. So it is temporarily change in the voltage by the device, and this required voltage is obtained by taking the voltage without sag and essentially these affect the event. So you can see the figure, see the equations. The equations of the voltage is x sin omega t minus phi minus input voltage. Then after we can find the voltage sag y sin omega t minus phi minus voltage after voltage. So the missing angle mt is find r sin omega t minus phi. Here the r is nothing but the अंडर रूट ऑफ द ए बी एन, जो हमारा जो इक्वेशन है ए माइनस बी ए प्लस बी माइनस 2ab cos phi is applicable. Then after the balance and unbalance, so the sag in the three phase can be balanced or unbalanced based on the occurs of the fault. So if there is the short circuit in the system when the fault occurs, and the voltage sag will have the equal magnitude in the all three phases. So the fault is unbalanced if the fault in the three phase of the due to the line to line or line to ground fault. We know that what is the difference between the balanced and unbalanced condition in the transmission system. Then after the point of the initiations, So it is the point at which the voltage sag is start. So it is occur during the post sag stage, यानी कि जो प्रीवियस का जो है स्टेज की सैग की सिचुएशंस उस पर डिपेंड्स है. सो द रिकवरी टेक प्लेस आफ्टर द फॉल्ट क्लियरिंग एंड द अनस्टेबल करस्पॉन्डिंग टू द zero crossing of the voltage. The next one is the point of the recovery. So it is the point at which the original voltage is recovered. The point of the recovery can be obtained easily than the phase angle jump. So the find the number of voltage sag of the recovery can be obtained easily than the phase angle jump. So here you can see that the characteristic of the voltage sags and the types of the voltage sag. जैसे ही आज के लेक्चर्स में हमने देखा कि टाइप्स ऑफ वोल्टेज सैग एक्चुअली है क्या, कि जो हमारा जो नॉर्मल वेवफॉर्म्स है वो वेवफॉर्म्स की जब हायर वोल्टेज होता है, यानी कि जो सैग हो जाता है उस ड्यूरेशंस में बहुत सारी दिक्कत होती है, यानी कि ओवरलोडिंग कंडीशन समझो हम, जैसे हमने आगे देखा था. जैसे यहाँ पे आप देख सकते हो कि जो वोल्टेज सैग है जो हमारा नॉर्मल वेवफॉर्म है उससे कम वेवफॉर्म होगा. उसकी वजह से क्या होगा कि जो लोड जो होता है वो ज़्यादा पावर कंज्यूम करने के ट्राई करता है, तो उसकी वजह से बहुत सारे हमारे जनरली वोल्टेज सैग की इफ़ेक्ट ज़्यादा रहती है कि जब जो रिक्वायर्ड फ्रीक्वेंसी है उससे कम फ्रीक्वेंसी आती है. तो सो टुडेज़ लेक्चर में हमने देखा, आज के लेक्चर में हमने कि किस टाइप के वोल्टेज सैग होते हैं. सो देयर आर द टू टाइप्स ऑफ वोल्टेज सैग्स बेस्ड ऑन द फेज एंड द सेकंड वन इज़ द बेस्ड ऑन द फॉल्ट, यानी कि जो ट्रांसफॉर्मर वाइंडिंग है उसके रिगार्डिंग एंड लोड कनेक्शंस. सो बेस्ड ऑन फेज वी नो दैट देयर आर द सिंगल फेज इन आवर पावर सिस्टम, सिंगल फेज, टू फेज एंड थ्री फेज सिस्टम्स. सो ऑन द बेस ऑफ द फेज वो डिपेंड्स होता है कि अगर सिंगल फेज फॉल्ट है, जनरली हम जानते हैं कि मोर देन द 70%, जो 70% फॉल्ट्स होते हैं वो सिंगल फेज में होता है, यानी कि किसी टू लाइन कनेक्ट हो जाए, यानी कि फॉल्ट मोटर जाने तो लोड कनेक्शन सिंगल लाइन, जैसे कि होम अप्लायंसेस है या जो कंपनीज है उसमें जो मोटर हम स्टार्टिंग करते हैं इनिशियली में, तो उसकी वजह से जो होता है वो मैक्सिमम 70% फॉल्ट होता है. देन आफ्टर द टू फेज फॉल्ट्स जो लेस देन द 10%, यानी कि दो लाइन टू ग्राउंड और ग्राउंड टू लाइन फॉल्ट होता है वो. एंड द वेरी लेस effect in our power system is the three phase fault. Then after the connections of the transformer, हमको पता है कि there are the transformer connections, the primary and the secondary side is the delta to star connections, star to delta connections, and delta to delta connections and star to star connections. So here most ofly these combination is affect our the voltage sag systems, क्योंकि हम जब स्टेप अप या स्टेप डाउन करते हैं उसकी वजह से हमारी जो फ्रीक्वेंसी है उसमें डिस्टर्बेंसेस ज़्यादा जनरेट होता है. सो द कैरेक्टरिस्टिक, तो वोल्टेज सैग की कैरेक्टरिस्टिक जनरली मैग्नीट्यूड पे डिपेंड है, देन ड्यूरेशंस कितना टाइम लगता है, देन आफ्टर द फेज एंगल जंप यानी कि जो फेज में इफ़ेक्ट होती है वो, देन मिसिंग वोल्टेज, then balance and unbalance conditions, then point of the initiation यानी कि जैसे कि मोटर है तो इनिशियल लेवल पे जो पावर कंज्यूम करता है उसकी वजह से वोल्टेज सैग की कैरेक्टरिस्टिक में इफेक्ट होता है. एंड द लास्ट वन इज द पॉइंट ऑफ द रिकवरी. सो दीज आर तो मेथड ऑफ द फाइंडिंग द मैग्नीट्यूड of the voltage sag is depends on the RMS voltage methods, then peak voltage method and the one cycle window algorithm systems, and the last one is the half cycle window algorithm system. So these are the magnitude, यानी कि nothing but the जो हमारा वेवफॉर्म है, अगर मैं RMS वोल्टेज की बात करूँ तो पॉजिटिव पीक वैल्यू टू नेगेटिव पीक वैल्यू, उसको टोटली मैग्नीट्यूड कहते हैं. देन पीक वैल्यू यानी कि 0 टू जो मैक्सिमम वेवफॉर्म है उसका पॉइंट. देन आफ्टर द 1/2 साइकिल एंड द 1 साइकिल एंड 1/2 साइकिल वी नो दैट दी व्हाट इज दी 1/2 साइकिल एट. तो वो पूरा कैलकुलेशन जो एक साइकिल जो पॉजिटिव से लेके मैक्सिमम पॉइंट 0 माइनस नेगेटिव पॉइंट एंड 0 जो पूरी साइकिल होती है उस डिपेंड पे मैग्नीट्यूड फाइंड कर सकते हैं. So these are the characteristics. So if any questions regarding this topic, you can call me. If any question arise, then you can mail me. My mail ID and the contact number is in your screen. Thank you.